Class 8, welcome back to the live class. Due to some reasons, I could not take the live class last week, so I'll be continuing with chemistry. And we will do the second chapter today, that is physical and chemical change. And as for the notes on the first chapter, I'll be posting it within this week. Okay, yesterday I was supposed to post it, but somehow I could not do it, so I'll be posting it in the next, maybe tomorrow. I think I have a WhatsApp, I have to post it, so I'll do it tomorrow. I'll be posting the valency also, valency chart, which I had posted in class 7 group, so I'll be posting it in class 8 so that you revise and learn it by heart, the valency. Okay, so today we will talk about the physical and chemical changes. We'll talk about changes. So we know that in everyday lives they are full of changes that we observe every day. Like the sun shines brightly in the morning, the day changes into, the night changes into day, and the day changes into night, and so on and so forth, isn't it? So these type of changes, they take place continuously, always. We like changes, isn't it? So you can observe the man-made changes like burning of fuel, the cooking of food, and the formation of curd into milk, and the natural changes like the growing of seed into a plant, or small tiny plant into a tree, isn't it? The ripening of fruits, and these are natural changes, and they are man-made changes. So broadly we can talk about in this chapter, according to this chapter, we will deal with the physical and the chemical change. So what is a change? A physical change is a change in which no new substance is formed, and the chemical composition remains unaltered. It will not change. The property of a substance which is undergoing a change, there is no chemically there is no change. It will remain the same. There is a change only physically. So that is called physical change. A physical change is a change in which no new substance is formed and there is no alteration in the chemical composition. So that is called a physical change. For example, like you dissolve common salt or sugar in water. That is a physical change, isn't it? Why is it a physical change? Because no new substance is formed. Sugar remains as sugar and water remains as water. And how can you say that is? The water itself becomes sweet because of sugar. That means there is no alteration, there is no change in the chemical properties of sugar. The sweetness doesn't change. That means no new substance is formed. So therefore, physically there might be a change, but chemically there is no change. So therefore, this type of change is called a physical change. Like glowing of a bulb. Now when you switch on the switch, of course, what will happen? The bulb will glow. And then you switch it off again, the bulb will stop glowing. But there is no new change, no new substance is formed. So glowing of electric bulbs are also known as chemical change. Physical change. So we come to the characteristics of physical change. So a physical change is certain physical properties such as state, color and shape may change, but chemically it will remain the same. There is no change, there is a change in the state, means physical state, solid into liquid, liquid into gas. There is an interchange of state of matter. In a physical change, there might be a change in the color, there might be in the change of the shape, but chemically it will remain the same. So these type of changes are called physical change. Now, the characteristics of physical changes are: number 1, generally the change is temporary and can be reversed by changing the condition. So I'll give you an example on this. Generally, there is no change. The change is temporary. It is not a permanent change. For example, and it can be reversed by reversing the conditions. For example, like water. You put it inside the refrigerator in the deep freeze. What will happen? It will solidify, it will change into ice. There is change in the physical state. But chemically, the chemical nature of water will not change, isn't it? So, chemically it remains the same. But now you heat it. Heat the ice, it will turn back, it will change back into water. So it is a temporary change. So it can be reversed by reversing the condition. Previously, we put water and we cooled the water. Now you reverse it, you heat the ice, it will change back into water. It will melt back into water. So physical changes normally, usually can be reversed by reversing the conditions. Number 2, no new substance is formed. Please remember that in a physical change, no new substance is formed. That means there is no alteration in the substance chemically. There is no chemical alteration of a substance. So, there is no change in the mass of the substance, no change in the chemical nature, nor is there any change in the mass undergoing a physical change. So, physical change, no new substance is formed. The third point is, there is no change in the chemical composition of the substance. The original substance will remain as it is chemically. Physically, the color might change, the state might change, and the shape also might change. But chemically, it will remain the same. There is no alteration in the chemically of a substance. The fourth point, there may or may not be change in the physical properties such as state, shape, color compared to its original form. So, and the last one is, no significant change in energy takes place. So, there is no change in the energy. Alright. Now, we come to the chemical change. A chemical change is a permanent change. Remember, a chemical change is a permanent change in which the original substance loses its own composition and properties. That means a totally new substance or substances are formed in a chemical change. So during a chemical change, one or more new substance with a different composition is formed. So there is a change in the chemical property of a substance. Then we consider this type of change as a chemical change. Like if you burn a piece of paper. You must have seen, you burn a piece of paper, a totally new substance is formed, that is carbon dioxide and water vapor, as well as ash. You have seen the ash. The totally new substances is formed. Like for example, if you burn LPG gas, you may not see any change, but there is a chemical change. Like for example, if you burn LPG gas at home, that is liquid petroleum gas, chemically it is known as butane, mixed with other gases, of course. So butane, when any hydrocarbon which burns, butane it burns, like maybe you are burning butane or you are burning candle, what is formed? Totally new substance is formed. You may not see the change, but totally new substances are formed, that is carbon dioxide and water vapor. And of course, heat and light is given off, but along with the heat and light, when you burn LPG gas or a candle or any fuel, carbon dioxide and water vapor are formed. These are the two substances, new substances that are formed. Okay, so it is a chemical change. So there is a change, alteration in the chemical nature of a substance. So if you burn a piece of paper, new substance is formed, like for example smoke, ash, water vapor and carbon dioxide is formed. So the molecules of paper and the oxygen combine and undergo a change to form the molecules of a new substances. So therefore, the change is permanent and cannot be reversed. The change, chemical changes, all the chemical changes without any doubt, we can say that all the chemical changes are permanent and cannot be reversed. Like when we talked about the physical change, like melting of ice. When we heated the ice, it melted into water. If you want ice back, that, then what do? Reverse the condition, we get the ice back from water. So water you can melt it, ice you can melt it into water, and water you can change back and turn back into ice, which can be reversed. But chemically, totally no new substance is formed in case of the physical change of water into ice or ice into water, or there is a change of state. But in the chemical change, the change is permanent and cannot be reversed. You cannot get back the paper if that is burnt. Okay, you cannot get back the fuel that is burnt. It changes into carbon dioxide and water vapor. All right. So chemical change is a permanent change. It is not a temporary change. It is a permanent change, and new substance will be formed. So you cannot combine the ash, the water vapor, and so on into paper again. So that is a chemical change. Thus, burning of paper is a chemical change, because we cannot reverse. If you reverse the condition, you cannot get back the original substance. Totally new substance will be formed. Now, we talk about the characteristics of a chemical change. The following are the characteristics of chemical change. Number one, the first one is one or more new substances will be formed with different chemical composition and different properties. Okay, totally different from the original substance. So new substances are formed. The point number two says the change is permanent and irreversible. Like we said, when we burnt paper, you get ash, smoke, carbon dioxide and water vapor. You cannot get back the paper back again. So it is a permanent and irreversible change, unlike the physical change. The point number three, an energy change is generally involved in a chemical change. The energy is either absorbed or evolved during a chemical change. When a chemical change takes place, there is absorption of heat energy, and the change is said to be endothermic. And when a chemical change takes place with the evolution of heat energy, then the change is said to be exothermic. So there is a change in the energy when chemical changes take place. All the chemical changes takes place when the chemical reaction takes place or chemical change takes place. It takes place whether either due to the evolution of heat energy or the absorption of heat energy. Okay, so and a chemical reaction which absorbs, which gives out heat energy, the chemical reaction which emits or which evolves heat energy is known as exothermic reaction. Like, for example, burning of food in our body, respiration. So when the food in our body reacts with the oxygen, so oxidation of food takes place, which results in the evolution of energy in the form of heat also. That's how we get the body temperature. Okay. Like you burn candle. Obviously, when you burn a candle, what happens? It evolves heat. So that is exothermic reaction. An endothermic reaction is a reaction. I'll give you one more example of an exothermic reaction where heat is evolved. So what you do is you get a little bit of calcium oxide, to which you put cold water. Okay, in Nepali we call it chuna, and in chuna you put water, cold water. What happens? The water will start the boiling. That means water, when it comes into contact with calcium oxide or lime or quicklime, it changes. A lot of heat will be produced and changes into calcium hydroxide. So it evolves heat. The heat is produced. So therefore, it is called exothermic reaction. So a reaction in which heat is evolved is called exothermic reaction, and just the opposite, the reaction in which heat is absorbed is called endothermic reaction. And the point number 4 says, the last point, the mass of the substance undergoing a chemical change is generally altered. So there is a change in the mass. Like, for example, when you burn a piece of paper, naturally what happens? There is a change in the mass, isn't it? So In a chemical change, usually there is a change in the mass. However, it may be noted that the total mass of a substance involved in a chemical change remains the same. Now, you must be wondering how it is so. So, like you burn a candle. Okay, when you burn a candle, naturally the candle becomes smaller and smaller and smaller. It's a chemical change. It evolves heat, it evolves light and produces carbon dioxide and water vapor. Is it not? So the candle becomes smaller and smaller. Usually the mass decreases as we see. If we see the mass decreases, but in the chemical reaction says in a chemical change there is a change in the mass. But actually, if you trap the carbon dioxide and the water vapor which is produced during the burning of candle, the mass of the candle and the mass of the carbon dioxide and water vapor which is evolved, it will be equal. So there is no change in the mass actually, if you see. Okay, so hence the mass is neither created nor destroyed during a chemical change. Actually, when we see physically, there may be a change in the mass, but actually there is no change in the mass. The mass of the reactants and the mass of the products will be the same in a chemical change. So this is called conservation of mass. Okay. So now we have discussed today the different types of changes, the man-made change and the natural change, and basically we talked about in detail, we talked about the physical change and the chemical change. So in the next class we are going to talk about the changes involving energy, changes in the physical state, and why there is a change in the physically if you heat a substance, and so on and so forth. We'll come to that later in the next class. But for now, this much for today. Thank you so much. I hope you understood.